Okay, so in this video here, we're going to be talking about compound inequalities. And before you can solve a compound inequality, you have to know how to solve normal inequalities. So if you don't know how to solve an inequality, go ahead and check my video on solving inequalities. I will go ahead and link that below in the description box. That way you have access to that content. And so let's get right into this video here dealing with compound inequalities. So before we go into our examples, you have to know a couple of things here. And that is there are two different types of compound inequalities. You could have a disjunction, which would be or you could have a conjunction, which would be and. So with a compound inequality, you have two different types. You have or and you have and. And again, or will be a disjunction, while and will be a conjunction, right? But all you really have to remember is or and. Now, if you have an or compound inequality, 99% of the time, they're going to be opening away from each other. So I gave you an example here. You're going to be graphing two solutions, and 99% of the time, they're going to be opening away from each other. The other 1% of the time could be a special case, and we will go over that in this video at the end. Same thing with and, okay? You're going to graph two solutions, but now they're not going to be opening away from each other. They're going to be opening towards each other. And again, 99% of the time, if you're dealing with and, they're going to be opening towards each other, right? As you can see down here, okay? Now, again, there is a possibility where that may not happen, and that's a special case, and we'll talk about that again at the end of this video. All right, so let's go ahead and take a look at our first example. So here's our first example. We're dealing with or, so we're dealing with a disjunction, and they want us to solve and they want us to graph. So your first step here is to actually solve each one of these inequalities, okay? So that's what we're gonna do, and then we're gonna go ahead and graph them. So on the first one, I have to -6 on both sides. That will cancel out here, and then I bring down n, bring down my inequality, -1 and a -6 make -7, and there we go, that one's done. Then we have or, so it could be this, or it could be what we're about to solve here. I'm going to divide both sides by -5. Now remember your rules. If you divide by a negative or multiply by a negative and you're solving an inequality, you have to flip the inequality sign. So I'm going to go ahead and circle it so I don't forget. And now I'm going to write my final answer. I have n, and instead of less than, it's going to be greater than now. I have to flip it. And when I divide two negatives, it becomes a positive. I get +4 here. -20 divided by -5, +4. So those are my two solutions. And let's talk about graphing it now. So make a number line, and you're going to put both of those values on the number line. Okay, so here's 0. -7 will be over here. We'll say that 4 is right here. So on -7, I'm going to have a closed circle because it's equal to. So let's go ahead and do that. On 4, it's going to be open. It's not equal to, right? And so again, like I told you at the beginning of this video, 99% of the time, these are going to be opening away from each other. And again, you can just read the statements to confirm. It says n, or all real numbers, has to be less than or equal to -7. That means I'm going to the left, okay? Then I look at the other statement. It says n, or all real numbers, has to be greater than 4, okay? So that means I'm going to the right. So when you're dealing with a compound inequality like or, it could either be this one or this one that satisfies the inequality. So for example, if you read it, it says all real numbers that are less than or equal to -7, or it could be all real numbers greater than 4. Okay, so for example, if I put in 5 into one of these inequalities, it's only going to satisfy this inequality here. It won't satisfy this one. Okay, but it doesn't matter. It only has to satisfy one of the inequalities when you're dealing with or. Now, if it were and, it would have to satisfy both of them. Okay, so that's kind of the key difference there. And so this one's done. All right, so you can see it's graphed, it's solved, and they're opening away from each other. All right, let's take a look at our next example. So here's our next example. It's a little more challenging. It's a multi-step inequality, and we are dealing with or, so we have to go ahead and solve both of these first, and then we can go ahead and graph it. So I have a variable on both sides. I'm going to have to move that over. So we're going to do this all in one go. I'm going to move the variable over to the left-hand side and my constants over to the right-hand side. So that means I'm going to -6n here and also here. And again, doing it all in one go, I know that this is going to cancel. I can then take this +4 and move it over, so I'm going to -4. Again, we're going to do it all in one go. This cancels. 4n, -6n, that gives me -2n. Less than or equal to -10 and -4 give me -14. My last step, divide both sides by -2. Now remember, I did divide by a negative here, so I need to go ahead and flip the inequality. I'm going to circle it so I don't forget. So I get n is greater than or equal to, flipping it, right? +7. Okay, there it is. Let's go ahead and solve this one now. We're going to do the same thing. We're going to move the variables over to the left-hand side, the constants to the right, and then we'll solve it. So -4n, -4n, okay? This will cancel. Let's -2, -2. This will cancel. 2n minus 4n, -2n. Greater than or equal to 8 plus a -2 will give you +6. My last step, divide both sides by -2. I did divide by a negative, meaning I have to flip the inequality. Okay, so I get n no longer greater than or equal to, I'm going to flip it, so now it's less than or equal to, again, a positive divided by a negative, I get negative here, -3. Okay, there it is. So again, you do have or right in between both of these inequality statements. So again, if you read the problem, it says all real numbers, or n, has to be greater than or equal to 7, or all real numbers less than or equal to -3. So again, those are going to be opening away from each other. So let's go ahead and put on our number line. Here is 0. Here is -3. Here's +7. So on +7, I have a closed circle. On -3, I also have a closed circle. In reading the statements, we can see that we're going to be opening away, right? Going to the left here and going to the right here. Okay, so that one's done. Okay, so now let's try some examples dealing with and. So here's our next example. You can see that we're dealing with and now. So this is no longer a disjunction. This is going to be considered a conjunction. But again, all you really have to remember is and or, okay? So what we want to do is solve both of these first, and then we're going to graph just like we did before. So right here, I'm going to divide by 3. So dividing both sides by 3, I get n is less than 27 divided by 3, I get +9, okay? Then I put and. To solve this one, we're going to have to multiply both sides by 2, right? We want to get rid of that denominator of 2, so we're going to multiply both sides by 2. This will cancel. I get n is greater than 0 times 2 is 0, okay? So what we're saying here is the following. We're saying that all real numbers, or n, has to be less than 9, and all real numbers have to be greater than 0. So in order for that statement to be true, you can see that we're going to be opening towards each other. So when I graph both of these points on the number line, they're going to be opening towards each other. All right, so let's go ahead and do that. Make our number line. This will be 0. This will be +9. And they're both going to be open circles. Okay. So again, we don't want to shade past though. We just want to shade in between. So right in between is going to be our solution. We don't want to go past. Okay, because again, all real numbers have to be less than 9, and all real numbers have to be greater than 0. That's going to be this region and here, right? And so that's how you would graph a conjunction, right? An inequality dealing with and. Let's go ahead and try another example. Okay, so here's our next example, and you may have noticed that you don't see the word or and. Now, what type of compound inequality is it going to be? Is it a disjunction or a conjunction? And this is actually going to be a conjunction, meaning it's going to be and, okay? And we know that because it's using two inequality symbols, okay? I have an inequality right here, and I have an inequality right here. Whenever you see a statement written like that, using two inequalities, you know that you're dealing with and, okay? You can never write or using this type of format. So or will never be written in this format here, only and. So if you can remember that, you're fine. You know that you're always going to be dealing with and, okay? So this is going to be and. So how do we solve it? And it may not seem obvious at first, but there's a couple of different ways in which you can solve it. So for example, let me get rid of this here. The long and drawn out way of solving it would be to break it down into parts. So you could do this part right here, going from here to here. That's one inequality. You would solve it, get x, and then go from there. Then you would break it down into this part here, going from here to here. That's another inequality. You would solve it, get x, and then you'd have your two inequalities that you can graph, and so on, right? But there's actually an easier way. This method here is actually inefficient. The more efficient way of doing this problem is going from the inside out. So for example, I want to go ahead and isolate x. I want to leave it in the middle of these two inequality symbols. That's my goal. Okay, whenever you have a statement written like this, you want to leave it in the middle. So to do that, I just have to balance it on all sides. So for example, my first step here, if I'm going to work from the inside out, I want to get rid of this positive 2. So I'm going to minus 2. But that means I have to do it on all sides. Just like when I balance out an inequality or an equation, I have to do it to the other side as well. Well, I have two sides here. I have this side and I have this side, okay? So we're going to have to do it 2 more times. So for example, I'm going to minus 2 here and also here, okay? And then we're going to go for it. So this will cancel here. Here I get negative 38 and negative 2. That gives me negative 40, less than 4x, and then less than negative 36, right? Negative 34 and negative 2, negative 36. And from here, now all I have to do is divide by 4. So I'm going to divide by 4, and I'm going to divide everything by 4. Okay, there we go. This will cancel. I get negative 40 divided by 4. That will give me negative 10. Now remember, I did not divide by a negative. I do not have to flip the inequality signs, right? So I'm good there. Just going to rewrite it. This will give me x. And then rewrite this inequality. Negative 36 divided by 4, that will give you negative 9. So what is this statement saying here? This statement right here is our answer, and it's saying the following. It's saying that x has to be greater than negative 10, and it has to be less than negative 9. All right, so when we graph it on a number line, we're going to be shading in between. So here's my 0. I'll put negative 10 right here. Negative 9 right here. Both of them are going to be open circles, so open circle here and here. And again, in order to make this statement true, x has to be greater than negative 10 and less than negative 9. That means I'm going to be shading in between here, just like that. Okay, that one's done. So again, the takeaway here, when you're dealing with or, again, 99% of the time you're going to be opening away. And with and, 99% of the time you're going to be shading in between. Now, the next example is going to be a special case where that is not going to be true. So let's go ahead and take a look at that example. So here's our last example, and these are going to be special cases where that's not going to be the case. So for example, I'm dealing with or here. They're not going to be opening away. And this one's and, they're not going to be opening towards each other, and you're going to see why. So let's go ahead and do the first one. We're going to deal with this disjunction first, or. So first we're going to solve it, and then we're going to graph. So right here, I have the minus 1 on both sides, okay? This will cancel. I get n is greater than 1, okay? That one's solved. Or here I have to divide both sides by 4. When I do that, I get n is less than or equal to 6. Now, you have to think about this statement logically. This is going to be my final answer, right? What this is saying is all real numbers that are greater than 1 or all real numbers that are less than or equal to 6. So if I were to graph that on a number line, how does that look? Well, let's take a look. I have 0 right here. Here I have 1. Here I have 6. So again, graphing the first one, that's going to be an open circle. It's saying all real numbers greater than 1. So all real numbers greater than 1, well, that's going to be in this direction here. And then the next statement, or what? All real numbers less than or equal to 6. So that's a closed circle, and it's going to be going in this direction here. So what do you notice? Well, you should notice that they're overlapping, meaning I'm including all real numbers on this number line. This is a special case. They're not opening away from each other. If you end up with a case like this here, this is going to end up being all real numbers. So the answer here, or your solution, is all real numbers to this problem, okay? All real numbers are going to satisfy this compound inequality. Doesn't matter what number I plug in, it's going to satisfy this inequality, right? So again, all real numbers. So that's a special case when you're dealing with or. Let's take a look at and. So when you're dealing with and, first we have to solve it. So again, I have two inequality signs. I know I'm dealing with and. So my first step, get rid of that 4. I have 4 times b. That means I have to divide all sides by 4. So I'm going to divide by 4 here, here, and here. So 0 divided by 4 is 0. Less than or equal to b, less than negative 4. Okay? Now we have to graph it. So here's my statement. Go ahead and box that in. So from here, let's go ahead and put it on a number line. So here is 0. Put negative 4 right here. So on 0, it's going to be a closed circle. On negative 4, it's going to be an open circle. So again, read your statement. What is it saying? Well, it's saying here, b, or all real numbers, have to be greater than or equal to 0 But then it's also saying and less than -4. Remember, you have to satisfy both of those inequalities when you're dealing with and. So again, all real numbers that are greater than or equal to 0 and also less than -4. Well, that's impossible. I can't have a number that is greater than or equal to 0 and also going to be less than -4, right? It's impossible. So for this one here, it's going to be no solution. We can't graph it. So I'm just going to put no solution. Okay, this one cannot be graphed. Okay, it's impossible. You cannot have a number that is greater than or equal to 0 and also less than -4. It does not exist, right? So that's a special case when you're dealing with and. You could end up with no solution, right? It's an impossibility. You can't graph it. So technically, this would be incorrect here, right? That would not work. So that is it. That is compound inequalities. That is how you solve compound inequalities, whether you're dealing with a conjunction or a disjunction. Remember, conjunctions are and, disjunctions are or, and that's pretty much all there is to it. So I hope that the video helped you. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.